This is video number 2 in proportional relationships. In the first video we focused on tables, and in this video we are going to focus on graphs and identifying whether or not the graph is showing a proportional relationship. As within tables, a common unit rate is going to be found in a proportional relationship if it is shown in a graph or if you are asked to graph a table and determine if it is proportional. So we're going to start with some examples right away since we already know how to identify or test for a proportional relationship. This problem says the black mamba is the fastest snake in the world. The table shows the distance the snake travels for several different times. Is the distance the snake travels proportional to the time? So the table is given to us, and we're going to consider that our table would represent time would be our x, and distance would be our y. So time in seconds and distance is measured in meters here. And so if I bring the graph over, we're going to identify that those points from the table have been graphed appropriately. 0, 0, 1 second, there's been a 5-meter distance, 2 seconds, 10 meters, 3 seconds, 15 meters, 4 seconds, 20 meters. And then we've connected the ordered pairs, showing how that line would continue for 5 seconds, 7 seconds, etc. So now our job is to determine whether or not this is proportional. So you're going to go through the same steps that we did while just looking at a table. All right, and we're going to determine what are we comparing and then do all of our values from the table, simplify to give us a constant of proportionality, or that same unit rate for every single second that's measured here. So if I take a look at my table, I notice that I am thinking about kind of speed, so distance compared to time, so y over x for my distance over time. So I have 5 meters over 1 second, and I'm going to test to see is that equivalent to 10 meters over 2 seconds. So remember from our last video we said we could cross multiply and check if our cross products were the same. So 5 times 2 is 10, and 1 times 10 is 10. So our first two values in the table are proportional, or are equivalent. So now let's see if the next couple are as well. So we have 15 compared to 3 seconds and 20 meters in 4 seconds. And if I cross product check this, 15 times 4 is going to give me 60, and 3 times 20 gives me 60. So it seems as though I have 4 ratios in my table that are all equivalent. But now if we take a look back at the very first value, we see the 0, 0. And 0, 0 tends to be a little bit tricky to think about because we often say, well, that's not going to have that same unit rate. However, if we take a look here and set this up using that same idea of a cross product check, if we have 0, let me get my pen back here, 0 over 0 is equal to 5 over 1. When I check my cross products, I'm still going to get a 0 is equal to 0, which allows me to identify that yes, in fact, my entire table is going to be proportional. So now that I've identified that the table is proportional, that also means that my graph is proportional. So a few things have to be true in order for my graph to be considered proportional. And one of those things is that I have to have a linear relationship. So my line has to be linear, which the simplest way to describe that is it's going to have a constant rate of change, or it's going to be a straight line. All right, and that straight line can have a different slope or a different kind of height, thinking about it growing, or even a decrease depending on what we're just speaking of. So it has to be linear. It has to have the same unit rate between all of those points, or that constant of proportionality, and it has to go through the origin. And remember, the origin is where my x and y axis are going to meet, and it is considered that 0, 0 place. So this relationship between distance and time for the black mamba snake is proportional. Ms. Saarinen plans to save $20 each week for a trip this summer. So let's look at the graph and determine, does this situation represent a proportional relationship? It says create a table, an XY table of points on the graph. Test the data points on the graph. Is there a constant of proportionality or that same unit rate? Is the graph linear? And does the graph go through the origin? So in order to start this, I'm going to attempt to squeeze this down. Maybe I'll just move it like this. How about here? Okay, so let's make a table. And the table I'm going to make is going to be that XY table. And you can have it be a vertical table or a horizontal table. I find that it's a little bit easier for some people to look at this as a horizontal because then your ratios are already set up. And we just need to determine what do we see on our table. So I'm going to jump over and I'm going to see that I've got 240. So 2 weeks, I would say $40. And after 5 weeks, it appears as though I have $100. 5 and 100. And 7 weeks is 140. 7 weeks is 140. Okay, so notice it doesn't have to be every single data point. I just want to get a good sampling of them, and it's probably a good idea to have at least 4 or 5 values. So let me pick one more off the table. Let's go up to 10 weeks, and that gives me 200. So 10 and 200. Okay, now notice I didn't pick the numbers that are near the bottom, but I could go ahead and look at that and say, well, 1 is 20. So if I put 1 week is $20, ideally I want every single ratio in this table, which are located, the points are located on my graph, to give me $20 per week. All right, remember our Y is money saved and our X is weeks. Okay, because that would give me my constant of proportionality or that unit rate. So now go ahead and quickly check a couple of these. All right, hopefully some of you are already looking at this graph and saying, well, wait a minute, it looks linear, and wait a minute, it's going through the origin. So this seems to be proportional without actually checking the points, but we still have to check our points. So I'm going to have my, we can do X over Y, that's fine. So 2 compared to 40, I can simplify that by dividing both by 2, and I would get 1 to 20. Okay, so that's a good check. And then I'm going to check my 5 to 100. Both of those could divide by 5. Gives me 20, gives me 1. That's a good check. Okay, so you can see, I'm not going to check all of them because I already know this, and I think that some of you are already anticipating this, that 7 weeks and $140 shows a 1 week for every $20, and 10 to 200 shows that for each week in those 10 weeks, $20 have been saved. So the next part of this is to determine whether or not we see that this is linear. Okay, so linear shows that this line here is going to be growing at about the same, or not at about, but at exactly the same slope or rate of change, which it is, and it also has to go through the origin. Okay, which means that after 0 weeks, how much money has been saved? Well, if we're starting with $0, after 0 weeks, you're going to have $0. Okay, so this graph also shows that it would go through the origin. So this situation is proportional, and the unit rate would be $20 per 1 week. All right, so for this word description, you're going to have to determine, well, what the table would be and then possibly make a graph. And so I'm going to go through this one a little bit of a different order just because sometimes this is asked of you, and you can still use your table and a graph to determine whether or not you have a proportional relationship. So this says a candle is 20 centimeters tall. It burns at a rate of 2 centimeters per hour. So when I read that, I think, wow, that's pretty pretty telling information, because it tells me that the unit rate is 2 centimeters per hour. So that seems like this is going to be a proportional relationship. So is the height of the candle proportional to the number of hours it burns? So I'm going to use that kind of question set, or things that I can do to determine if this is proportional. I'm going to create a table of X and Y. I'm going to then test the data points and take a look at the graph. And so I'm going to do this one in a little bit of a different order, except for that I think that you guys will be able to follow along. So the first thing I'm going to do is I'm going to start thinking about an X and Y table, where my X and Y table would be, the X would be my hours, and the Y would be how tall is my candle. So when I start burning this candle, or at the moment in which I'm going to light the candle, it's going to be 20 centimeters tall and 0 hours will have passed. After 1 hour, it burns at a rate of 2 centimeters per hour. So is my candle growing, or is my candle going to be decreasing in height? Right? Hopefully we've all had experience with candles, and we would say that that is decreasing in height. So after 1 hour of time, my candle will be 18 centimeters tall. And after 2 hours of time, it would be 2 less than that, which would be 16 centimeters tall. And 3 hours of time, I'm going to have 14 centimeters tall for my candle. So I can test these data points. I can also move right on over to looking at a graph, or graphing the data points if you don't have a graph to look at. So when we do that, the graph is going to look something like this. And so our graph shows after 0 hours, my candle is 20 centimeters tall. And just like I suggested here with the 3 hours, it was 14, all right, and it would continue to go on. So there does seem to be a unit rate, okay? And we seemingly have something that's linear, because the graph is showing a consistent change. Okay. However, because this graph does not go through the origin, this cannot have a proportional relationship. And because it doesn't go through the origin, it also means that it doesn't have a constant of proportionality or a unit rate. Okay. So we can't get tricked by the fact that this says 2 centimeters per hour, because although it is burning at a constant rate of change, it's not starting at the origin, which is going to leave us with not having a proportional relationship. So I'm just going to write a big not proportional here. So if you haven't already taken a moment to write down some notes about finding proportional relationships in graphs, I'm going to ask you to do that now. So the first thing you're going to do is to create a table, including your X compared to Y values of points that are found on the graph. So if you're given a graph, you're going to create an XY table. Then you're going to test the data points that are on the graph. So you've put those data points into your table, and from the previous video and our previous practice, you know how to test those data points. Okay, you're going to identify if there is a constant of proportionality or a unit rate. You're going to look at your graph. If the graph is linear, then you're going to look one step further and determine, does this graph go through the origin, giving a 0-0 relationship to whatever two values we're comparing. Okay, so pause the video, take these notes down so that we have a good way of determining proportional relationships when looking at graphs. All right, so this is the last example I'm going to do, and then I'm going to take that gold rectangle away, and you can do one in your notes for some practice before we visit this in class. So this problem gives me this idea that I'm comparing the number of tickets purchased and the cost that those tickets are going to be. So the first thing I'm going to do is I'm going to look at that table, but I'm going to go ahead and graph the information. So the number of tickets is going to be my X value. Let's see if I can change this to a different color. So this is going to be my X, and the number of tickets is going to be y. So actually I just reversed that. Number of tickets should be x and cost is going to be y. So tickets on my x-axis and cost on my y-axis. So here's my origin of 0, 0. I don't have anything to put there, so I'm going to plot 2 tickets as $6. This is going to be a little bit tricky to make it as exact as I'd like it to be, but that's alright. 2, 4, 6, 8, 10, 12, and I'm going to do the same information going up my y-axis. 2, 4, 6, 8, 10, 12, and 14. And let's go ahead and use green to plot these points. So as I plot the points, I see 2 and 6. It's a little bit off, but you guys get the idea. 4 and 8, 6 and 10, 8 and 12, and 10 tickets is going to be $14. Alright, so if I connect the points on my graph now, I'm going to connect something that goes pretty much like that. Okay, and so when I look at this, hopefully most of us are going to see right away that this graph does not go through the origin, which means that this would not give me a proportional relationship. It does appear to be linear because it appears to be in a straight line. But if we take a look at our table and try to test some of those values, we're going to find that we will not get the same cross products. Okay, so just if I go up here to the top of my table and take a look at 2 times 8 gives me 16, but 6 times 4 gives me 24. That is not going to be proportional. And I could test 2 more values. 4 times 10 is 40, but that does not equal 8 times 6, which is 48. Okay, so given the table, looking at the graph, checking my points that were in the table to begin with, this example is not proportional. Okay, so what I would like for you to do now is to go ahead and see if you can't, I have to figure out how to move that little rectangle for you guys. See if you can't, let's see, one more time. There we go, and we want to get rid of that. Get rid of it. Edit, send backward. Does that work? Nope. Oh, there we go. Okay. So, what I'd like for you to do now is to do 1B in your notes, and that's going to ask you to determine whether or not the number of hot dogs and the cost of those hot dogs shows a proportional relationship. So remember, if it does show a proportional relationship, you are going to want to determine what that unit rate is, and you should be able to show it on the graph, that that graph is linear, and that the graph goes through the origin of 0, 0. So now that you've completed watching the proportional relationship video on graphs, do you think that you could explain this in your own words if you had to tell somebody else in class, or another friend who's not in our math class, or one of your parents, how you could identify whether or not a relationship is proportional when looking at either a table or a graph? We'll discuss that in class. Have a good day, guys.